this lesson, we are going to work on the concept of continuity in calculus. In previous lessons, we talked about polynomials. The graph of polynomials are always continuous. The graph of a rational function is discontinuous when x is equal to a and x equals a is vertical asymptote. If you draw the graph of a piecewise function, the graph could be like this. We say it is discontinuous at x equals a, or as we saw before, we may have a hole on the graph of a function. These are type of discontinuity when we have vertical asymptote, hole, or jump on the graph of the function. And a continuous function looks like a polynomial. To define continuity, which is a very important concept in calculus, we say y equals f of x is continuous at x equals a if f of a exists. That means a must be in the domain of the function. Limit of f of x as x approaches a exists. That means both right side and left side limit of the function at x equals a exist. And limit of f of x as x approaches a and f of a are equal. If a function is continuous at every single point of an open interval, we say it is continuous on that interval. And we say f of x is continuous at x equals a from right side when f of a exists and the right side limit of f of x and f of a at a are the same. We say f of x is continuous from the left side. Similarly, when at b, the left side limit and f of b are the same. We say function f of x, y equals f of x is continuous on the closed interval of a and b. If it is continuous on the open interval, continuous at a from the right side and at b from the left side. Let's have a couple of examples. Example 1, f of x equals x2 minus 9 over x plus 3 is discontinuous at x equals negative 3. Simply because negative 3 is not in the domain of the function. We know f of x and g of x equals x minus 3 when x is not negative 3 are equal. Therefore, the graph of f of x is a line with a pinhole at x equals negative 3. Example 2. F of x equals 2x minus 1 over x2 minus 4 is discontinuous at x equals 2 and x equals negative 2. X equals 2 and x equals negative 2 are vertical asymptotes of the graph of the function. Therefore, function is discontinuous at 2 and negative 2. F of x equals 2x plus 1 when x is greater equal than 1, less than 1. X is discontinuous at x equals 1. The right side limit of f of x as x approaches 1 is 3, and the left side of limit of f of x as x approaches 1 is 1. Since limit of the function at x equals 1 does not exist, the function is discontinuous. For the first function, the discontinuity is called removable discontinuity. Whenever you have a hole in the graph, you basically can fill that hole by redefining the value of the function. The second one is called infinity type of discontinuity. And the third one is called non-removable, whenever you have a jump on the graph of the function. F of x equals 2x plus 1 when x is greater or equal than 2. And when x is smaller than 2, 5 is continuous everywhere. Since for x equals any number less than 2, it is a horizontal line, it is continuous. For x equals b greater than 2, it's a linear function, it is continuous. And at 2, it is continuous because the left side limit and right side limit of the function and the value of the function are the same. Therefore, f of x equals 2x plus 1 if x is greater or equal than 2. 5 if x is smaller than 2 is always continuous. Let's recap. In this lesson, we defined continuity. We know polynomial functions are always continuous. And rational functions are discontinuous at vertical asymptotes. And we have 3 types of discontinuity: whole, jump, and vertical asymptotes. Thank you.